Now, this is the second last lecture that I'm going to be giving to you next week, as well as covering some more React stuff. I will give you a specification, I guess you'd call it, for the first assignment. And I've forgotten the hand update, but I know you received a schedule from Jimmy on the hand ups for all our assignments. So I think it's around week 10-ish or so. But whatever Jimmy has given you is the date that we have given to him. So you have that detail yourselves. And anyway, the outline of the assignment, it's to build on, we're going to cover two more sessions or two more labs on the React app that we're developing in the labs. And then you can build on top of that. Now, if you want to use a completely different web API, then we will allow you to do that. You do need to check with us first, though, as to what you're planning to do if you're planning to go down that line. So this is this week's lab, or this week's section. There's no archive this week, but we will be using the archive from 2 weeks ago now at this stage, again in today's lecture. The topics today are the same as the last day. We're looking at routing. We're continuing our look at how we implement routing or navigation in React. And also there is a pattern that I didn't mention at all to you the last day, design pattern, which is very commonly used in all React apps. So we need to look at that today as well. And there's one other little use case that we will look at as well. The lab, as I said, is the continuation of the Movies app. So I guess I can start off the lecture unless there's any opening questions that you have for me. No. So here's my agenda. As I said, the last part is, okay, it's kind of technically it's a look at another aspect of routing or navigation, but it's something very specific. It's a very specific use case, a very common use case, and it's something that you will use in your assignment. I don't bring it into the lab as such, but I do give you a kind of a solution to this particular use case in today's lecture, and you can reuse that solution in your assignment. So navigation, we've looked at a number of aspects of the React router library. You might remember from 2 weeks ago that if we want to implement routing or navigation in a React app, which we always do really, then we need to use a third-party library, and there are many of them, and the most popular one, though, is the React router library. And we looked at some of the syntax and issues in relation to that the last day. So to continue on that discussion, another very common feature of any web app, be it React or otherwise, is that your pages tend to have a static element to them and a dynamic element to them. The static part of your web apps tend to be, you tend to have what we might call a website header or a page header and a page footer. And those headers and footers are consistent across all of the pages that make up your app. There may be a side menu as well. It's the same idea. These are static or unchanging from page to page. And so it's this part of the page that tends to be dynamic or vary as you navigate around the place. So the question is, how do we achieve these static parts? And in particular, in relation to React and using the React router library. So to give you an actual demonstration of it, we're going to use this fake email client that we're Maria developing in our samples from 2 weeks ago. So you might remember our email client had a home page it had an inbox page. I think that was about it, really. But maybe we might have some other pages as well. There might be a registration page, a contact us page, etc., etc. And for each of the pages, and I'm just showing you the home page here, we'd like to have this header on each of our pages, and we'd like to have this footer on each of our pages. And we want that to appear in all of our pages. So how do we do that? Now, this is, if going back to our routing samples, as I said, from 2 weeks ago, this is sample 6. And if I go over to my VS Code, I've loaded in the archive already. So, excuse me. So you know the drill now. I have to go into the space index.jsx and change it to sample 6, as I said. And I'll start up my development server. And so here's my header and my footer down here. And as I said, as we navigate around the place, so let's supposing I've got an about page, I've got a registration page, back to my home page. If I go into any particular inbox page, so the headers and footers are constant across the board. Now, the way we do that actually is, it's pretty straightforward. As it turns out, what I'm showing you here is the routing configuration for this app. And all that has changed really is I've added in this component, and clearly from the component's name, and this is a component that I've written myself. The header component is what's responsible for generating the page headers that you saw there a moment ago. And this footer component at the bottom is responsible for generating the footer on each page. And it's as straightforward as that, really. So we can actually mix in our own custom components into our routing configuration. Now, there's one omission in the archive that you would have downloaded from the website in order to get this working. And it is, I'm actually using, if I just go back to the web, I'm actually using the Bootstrap CSS library to generate this header and footer. In the labs this week, we will use Material UI to do something similar. But I think I omitted to include the Bootstrap CSS library in the archive that I gave you. So what you will need to do is, from the command line, if I just kill my server here again, from the command line, I've just put it into the README actually, although it's not going to be in your README now, but if I open up my README here, you will need to install Bootstrap using this command from the command line. And on doing that, then what you will notice is that in package.json, the Bootstrap library will appear. Okay. Now, in your case, as I said, in your case, initially, if you look at the package.json for this archive, the Bootstrap library won't be included in the dependencies. And so when you try and run sample 6, you're going to get a runtime error. Because if I look at, if I actually go into sample 6, and if I go into index.jsx, you see here at the top, it's importing the Bootstrap CSS, the CSS library, and that import is going to throw an error in your case. So install the Bootstrap library in the way that I showed you there a moment ago, and then run your development server, and everything will function as expected. So I'm not showing you the rest of sample 6 because there's nothing else new going on in sample 6 other than what I've shown you on the slides. So in other words, I'm looking at the base index.jsx, and here's my routing configuration. And there's my there's my header component as I talked. And here's my footer component. And the headers and footers are just these guys here. Okay, here's the header component. Nothing too exciting really, it's just standard JSX. It has no real functionality. And the footer is something similar. So that's that. The React library refer to these things as persistent elements, but are persistent components. Moving on, the next thing is programmatic navigation. So far, the only way we can navigate from page to page. I'm just slightly nervous. 1 second now. I presume people can hear me.
Yeah, I can hear you okay anyway.
Okay, yeah. You just never know from my side. I could be talking away and certainly there's nobody there. And usually it's as a result of me not turning something on or off or whatever. Right. Programmatic navigation. So far, the only way we can achieve navigation in our React app is through hyperlinks. But sometimes you may actually want to achieve it within your JavaScript code. So there might be an event handler, and one of the functions of that event handler is to redirect the application to another page. Yeah. And so we would call that programmatic navigation. How do we actually achieve that? Using the React Router library. There are 2 ways you can do it, and it's really a question of whichever you prefer. There are very rare cases where you might have to use one over the other, but they're very rare. So there's a declarative way of achieving it and an imperative way, and it's those 2 programming paradigms that I've mentioned once or twice to you now already. So with the declarative approach, you have to use a special you have to use a custom state variable, just a state variable, and you also use a component provided by the React Router library called the navigate component. And we'll see an example of this in a second. In the imperative approach, there is a hook provided by the React Router library called use navigate. So to illustrate this, it's a fairly kind of classic example of programmatic navigation. And it involves where you need to, if you're using an app and you need to register an account with the app itself. And so typically you might have some sort of registration button at the top of your page header. Now I've implemented the registration in 2 different ways to demonstrate the declarative versus the imperative approach, but both of these do the exact same thing. I've just implemented them slightly differently. And typically when you click on your registration button or hyperlink in this case, you're brought to the registration page. So that's normal hyperlink based navigation. You typically would have a web form here, which we needn't worry about. Fill out the web form, click the registration button. Clicking that button will trigger some sort of an event handler. Presumably the event handler validates what you fill in on the field, and if everything is fine, stores it in a database at the back end, and then eventually it will redirect you back to the home page. Now, it's this final redirection back to the home page that's carried out by the event handler, and so that's where we are going to implement programmatic navigation. So this is sample 7. So let's go back and switch over to sample 7. Oh, maybe I should start my server. Okay, so, it works as I said, whichever one of these I click on, then register, and brings me back to the home page, and they both do the exact same thing. So let's delve into the code. So these are my, sorry now. These are just my hyperlinks that I've shown you. And so you can see there's a register D for declarative, presumably, and a register I. So then there must be corresponding entries for those in my routing configuration, which there is. So if we look at the register D one first, it's implemented in this component called register declarative. Here's my register declarative implementation. So this is the one where we use a state variable and we use the navigate component. So this component displays my registration page, which is evidenced from here. And I've got the button that I clicked. And so it has an associated event handler. And here's the event handler. Now, here's my state variable. I've just decided to use a Boolean state variable. The type of the state variable isn't actually that significant, but I've decided to use a Boolean, and I've set it to false initially. And you can see here, I'm checking just within the component, I'm checking to see what's the Boolean or what's the current value of that state variable. And I'm saying if it's equal to true, which it isn't initially, then return this. So obviously this is skipped over the first time we load the page, which is why we just see the registration form. But when the user clicks the register button, the event handler runs, and the event handler changes my state variable, changes it to a true value. The component re-renders, as we know from before. Now on the second rendering, this statement is now true, as in my Boolean is now, my state variable is now equal to the Boolean true. And so instead of this overall component displaying the registration page, it now returns, if you like, this. Now, technically, returning a component means that this component is mounted onto the DOM, and technically that's what happens, but it doesn't actually display anything on the screen. What the navigate component does behind the scenes is it changes the browser's URL address bar. And in my case, I changed the URL address to just the root path, if you like. And we know from a couple of weeks ago that every time the browser's URL address bar changes, then the React Router library essentially catches that event and consults the routing configuration to decide what to do next. Now, because I've changed the browser's URL address to just /, that means it picks up, let's go back to the index.js. It picks up this entry here, and it just mounts the home page, which is exactly what happens. So in terms of programmatic navigation and a declarative approach to programmatic navigation, we have our state variable. We have our state variable, and we're using the navigate component to implement programmatic navigation for us. Yeah, that's that. The other approach is the imperative approach, and the imperative approach is implemented here. Similar kind of code, obviously. So the very first time this component mounts, which it does when the user clicks on the corresponding link in the home page, my registration form displays. Again, I've got my register button, on click event handler. In this case, here's my event handler. And the event handler is using a function called navigate. Now, this navigate function is acquired by using a special hook, the use navigate hook. The use navigate hook is provided by the React Router library, and it returns a function. You don't give it any arguments, it just returns a function. So this thing is a function. And you call that function passing it a path string. And what happens with what the navigate function does is it changes the browser's URL address to this string path. And again, the same story from there on in occurs, as in whenever the browser's URL address changes, then the React Router consults the routing configuration. So that's a more imperative approach towards programmatic navigation. It's all done by using this hook. And that's it, really. You will see a number of instances, or as I think about it now, do you? I think there are at least one, if not two, instances of programmatic navigation in the Movies app that you'll get to experience. Okay, that's that. There aren't any questions. I guess I'll move on. And move on as in summarize. So that's really, okay, there are other aspects to the React Router library that we haven't looked at, but we've covered all the essentials. And so what we can say about the library itself is that it in itself has a very declarative programming model, especially if you look at what I'm calling the routing configuration, that stuff that you put into the app component. That's very much declarative in style. There's a lot of component composition going on as well. You know, if I just refer back to the routing configuration of the most recent example, you know, there is composition going on here, as in we're composing the routers component with the browser router component. We're composing the routes components inside a routers, etc., etc. So it does follow a kind of a composition. There are other, you know, there are other routers as well, other than browser router. We will use one of them actually when we come back to revisit Storybook later on. But just say that there are other routers. And you may or may not know that the React framework can also be used for implementing native apps, as in apps that just run on your mobile device, or indeed apps that run on your desktop. And you would like to have navigation in those apps as well, but they're obviously not browser-based, so there are different routers for those types of use cases for the React Router or the React framework. So the other point is that behind the scenes, and I've explained this on some cases, the React Router library does follow this event state change re-render kind of model. Like every time, as I've kept on mentioning there a couple of times already in this lecture, every time the browser's URL address changes, that's an event. When that event occurs, the React Router library catches that event. It carries out essentially a state change internally, and, you know, etc., etc. I've already explained the other stuff that goes on. There are a number of components. Some of them we've looked at, but there are other components that come with this library. There are a number of hooks as well, and we've looked at some of the hooks, but there are others. So it's very much follows the overall React programming model, even though the React Router library is maintained by a completely separate team, if you like, or community. Okay, let's put that aside and change direction and go back to design patterns. So the design patterns we've looked at, those that are specific to React, the only one we looked at was the render props pattern. There's another pattern that I mentioned, if you go back and look at the other slides, called the higher order components pattern. Now, that was very popular a number of years ago, but it's not used, or at least I don't see it being used that much anymore. And that's mainly as a result of the introduction of hooks to the React programming model. So I'm not covering it formally. It's a nice one to read up on for yourselves if you like, and it is quite a nice pattern. It uses composition as well internally. I'm not going to look at that one. We also looked at the container pattern, if you remember. Pattern I want to look at today is called the provider pattern. Now, this provider pattern is not specific to React, or it's not specific to web apps. It's one of these patterns that was identified by the authors of that book I mentioned when I introduced this topic. So it has other applications outside of web apps. Clearly, though, the implementation of this pattern is specific. The application of the pattern, I suppose, is specific to React in our case, clearly. So there are some nuances to it, which wouldn't occur in the generic description of this pattern if you were to read up on it. And in that vein, what we're actually will be looking at when we discuss this pattern is something called React contexts. So context is a construct that comes with the React framework. And you could read a lot of articles about React context, this construct, and they may not mention the provider pattern at all, but they are linked anyway, the two fields, if you like. So when do we use the provider pattern? And it has a very specific use case in relation to React. And it is if you've got some data that a number of components, and typically it's data that you might have retrieved from your web API, but there are a number of components that need to access that data or need to know about it. In other words, it's shared data. So the question is, where should we store shared data? One place we could store it is in a component that's high enough up in the component hierarchy, such that any component that needs to know about it can receive that data from that higher level component by through the props kind of medium. Okay, so the higher component in the hierarchy could pass the particular data down to the subordinate components, and they might not be immediate subordinates. They might be subordinates further down the hierarchy, but pass them down as props. So that would work fine. But when you've got that kind of passing of props from components that are very high in the hierarchy to components that are much lower in the hierarchy, then you finish up with what is referred to as prop drilling. And prop drilling is often referred to as a code smell. It's something that we don't like to see in our code. This is a kind of a graphic of it that I found on the web, and apologies now about the emojis that are stuck into this thing. Whoever created it decided that was a good idea, but there you go. So here we have Maria, a component hierarchy for an app. And let's suppose in this component at the very top has retrieved some data from a web API, but some of that data is required by components further down the hierarchy. For example, this component here needs to know about some of that data because it wants to display it or do some computation on it. And this component as well needs to know, and this one needs to know about it. So what we could do is we could pass that data down as props down through the component hierarchy. The thing is, though, that these intermediate components don't really use the data. All they do is receive the prop and pass it on. Now, that is what we refer to as prop drilling. And we try to avoid it. if possible. So the two things, prop drilling and shared data that's used by a number of components, they're both, they're kind of two sides of the same coin, if you like. Is there a better way of achieving this sharing of data? And the answer is yes, there is, if we implement the provider pattern using the React context construct. So how do we go about it? So from a React point of view, I'm saying there are a couple of steps that we have to complete in order to implement this pattern. Number one, it all comes back to components at the end of the day. So again, we just declare a component that is responsible for managing this shared data. So that component typically would be the one that makes the web API call to retrieve the data from the backend. We refer to that component as the provider component. It's taking its name from the pattern, obviously. So that's just an ordinary component in one sense. Step two, we're told, is to create a context construct. We'll see how to do that in a moment. But we create this context construct anyway, and we link it to the provider component. We need to see how do we do that as well. Step three is, it says to wrap the shared data in the context. So if you like, the provider component is responsible for retrieving the data and storing it, presumably in a state variable. The context then also needs to somehow acquire access to that data. So the context, we're saying now, wraps this shared data. Step four is to compose using composition, and we have some idea how to do that. Compose the provider component with other components that needs to access this shared data. So we're going to use ordinary composition there. And having completed all of those four steps, our subordinate components, the ones that need to access the shared data, they will be able to access the data via the context construct directly. It does not have to be passed down to them via props. So this context construct, which is abstract for the moment anyway, it's kind of the key part of this provider pattern implementation in React. And a consequence of using it is it avoids this prop drilling code smell. And what's the second point I'm making? The provider component manages the context. Okay, so the provider component it's the provider component that decides what goes into the context construct, and consequently what is available to the other subordinate components. The subordinate components we can also refer to as consumers, as in they consume the contents of the context, as in they can access it. And the way they do that, the way they access the contents of the context construct, a lot of C words, is to use a hook called the useContext hook, which we'll see. This is kind of my visualization of it, if you like, sticking with the earlier picture that I showed you. So my context is my orange box on the top left there, Maria. And I have my subordinate components, my consumers are able to access the contents and indeed change the contents of the orange box directly. But what is inside the orange box is still managed by this provider component, which is now the name that I'm labeling this component with. Right. What I'm going to do is just show you excerpts from a kind of generic implementation of this pattern, given that we've kind of got a sense of the outline of how we implement the pattern. Let's look at some code specifically. So here's my provider component, and in one sense it's an ordinary component, in another sense it isn't, but initially it looks like an ordinary component. It's probably using the useState and useEffect hooks to acquire the data from the web API, the shared data, storing that shared data in a useState variable. Now, go back to the very first line here, right? This is how we create a context construct in React. So it's just a function. We invoke this create context function from the React framework. And here's my, if you like, here's my empty orange box. And I am exporting that context construct because it's going to be imported by the consumers, as well as exporting the provider component. Now, if we look at what the provider component returns, there's also a little, it's a little bit clumsy, but this is the way we have to do it anyway. Essentially, what we're returning is, you see here, I'm referring to the context.provider. So you're going to have to take this as boilerplate now, but really what I'm doing here is two things. One, I am deciding what actually goes into the context, what goes into my orange box, and that's decided or determined by this value prop. This is a prop that I'm passing to context.provider, and I'm assigning an object to it with key value pairs. So the key value pairs here, they are determining what is stored in my context construct. The keys can be anything you want them to be. The values can be anything, but typically the values would be maybe some or all of my state variables that I have up here. You can as well, actually, there may be functions that you implement here in my provider component. Typically, the functions would be concerned with making changes to my state variables. But if I do have functions here, I can actually include those functions in my key value pairs that I'm assigning to this values object. This values prop now is going to be significant in the next slide or two. Also, you notice here I'm going props.children. And so the effect of that, if you can remember, is I am going to be composing this provider component with other components in my app. Okay, and that composition is important, because if I don't carry out that composition, then the other components in my app will not be able to access the context. So the programming is a bit clumsy, I'll admit, but it's the way we have to do it. So number one, declare your empty context construct. And down here is how you determine, how you declare what goes into the context by means of this values prop that you pass to some context.provider. And we always compose our provider component with other components in my app. What the other components are, we'll see in a moment. Okay, the text here is just repeating what I've said. So that's my provider component and my context, and I've also populated my context. Next, we're looking at the second part of the composition that goes on between the provider and other components. And typically, you compose the provider essentially with all of the other pages in your app. And so that would mean all of the other pages now can potentially access the context, can access my orange box. So I'm actually doing the composition within my routing configuration. Here's my provider component. It's part of my routing configuration. And it's typically quite high in the routing configuration declaration. In my case, it's right beside the, right underneath the browser router component. And we would typically have, as we know now, we would typically have our various root components in here, which are our pages. And all of our pages are now being composed with the context provider component. So that's the composition. So that is the other side of props.children. Ignore this line here. This is actually the old way of mounting my app component to the DOM. So just ignore that. The last part of the jigsaw is my consumer components. My consumer components will presumably be either pages or components within a page. It doesn't really matter. If it's components within a page, they can still access the context because of the composition that's going on here. So here's a consumer. We don't know whether it's a page or part of a page. It doesn't really matter. Things to note are, it is importing the context. It's not importing the context provider. It's importing the context. On the right here, I'm actually repeating the provider component that I showed you 2 slides back. Here's the provider component from before. But I'm also, as I mentioned at the time, I'm also exporting the actual context construct. And that's what's being imported here. That's number 1. Number 2, for this component to access the context, it needs to use a special hook called the useContextHook. And the argument that we pass to the useContextHook is our reference to the context that we've imported. Now, this expression here, okay, what it returns is essentially the object that you assigned to the values prop over here. So in other words, that variable there is pointing at what I keep referring to as my orange box. But my orange box is this object here. And then we just dereference, we go, what am I doing? I'm just saying here that you kind of dereference in the normal way. So if you go context dot key X or key Y, where key X or key Y is one of the keys that you've declared over here, you're now essentially accessing a particular value within the context within the orange box. So it's by no means a clean implementation of the provider pattern, but there you go anyway. That's how you achieve it. And so that's kind of it, really. It's not until you do it yourselves, and you will get an opportunity to do it in, it's either in this week's lab or certainly in next week's lab. I think you do this week's lab as well, as it turns out, and next week's lab. And you'll also notice when you're using certain third-party libraries, if you pay attention to them, you'll notice that they use this provider pattern as well to expose certain functionality from that third-party library and make it accessible to your application. And that's what we will see next week in relation to this provider pattern. But we will implement our own custom provider pattern implementation for a particular use case that we have in our Movies app. There may be a number of different parts to this shared data that you want to make available to other components. And so rather than putting all of the data that needs to be shared into one context, what would be considered a better design is to have separate contexts for each particular aspect of the shared data. So having multiple contexts is actually a good idea. And so if you do have multiple contexts and consequently multiple context provider components, et cetera, then you would see them nested like this in your routing configuration. So this might be responsible for sharing one particular aspect of shared data, whereas this is concerned with sharing another part of the overall application's data model. That would be that's considered a good design rather than a bad design. A poor design would be just to lump everything into one context. A gotcha might be if one of these providers needs to access data from the other provider, then the order in which you put these is important. Other than that, the order is not important. So in my case, let's say if we looked inside the implementation of context provider B, we would see that it actually is a consumer of the context that has been defined by context provider A. That could arise in some cases. Now, only for completeness is why I'm including this slide here. We needn't concern ourselves with it. There are cases where you should not use the provider pattern implementation, even though you do have data that is shared by multiple components. One case in which you should probably not use the provider pattern is if all you're trying to do is avoid what I'm calling shallow prop drilling. Shallow prop drilling is where the shared data is managed by a component and it only needs to pass it down 1 or 2 levels in the component hierarchy in order to make it shareable. That's kind of acceptable prop drilling. It's only when you're passing it down through 4, 5, 6 layers in your hierarchy that you would revert to using this context idea and this provider pattern implementation. Now, admittedly, I probably break that rule in the Movies app, in the sense that I have shared data, and the prop drilling that would occur if I was not to use the provider pattern implementation would be considered shallow prop drilling. But I just wanted to give you an example of a full implementation of this pattern anyway in the Movies app. So potentially I am kind of breaking rule number 1 in the Movies app. The second case where you should probably not use, will definitely not use the provider pattern, is if the nature of the shared data is such that it is frequently changing. Don't use the pattern for that case. So a typical example of that would be, form data, where the user enters and the user may be changing the values on the forms multiple times. Every time they change it, that impacts the provider pattern. And the provider pattern, you see, does cause re-rendering every time anything within the context changes. And that re-rendering is quite expensive because the provider pattern, because the provider component is very high up in the component hierarchy, then lots of other components get re-rendered as a result. So avoid it in that case. The third case is if you're storing very large objects in your context, then you may need to reconsider using the provider pattern because it can have a fairly significant impact on your app's performance. I'm not going to go into explaining why that is, but it's the case anyway that you should reconsider. But in a way, you don't need to worry about 1, 2, or 3. I'm only mentioning these for completeness. Right, let me check the time. Okay, I'm very good on time this week now, so it's possible that I'm actually, for once, going to finish early. If you're a little bit woolly now on this provider pattern implementation, don't worry about it because, as I've said a couple of times already, you will use it in this week's lab. Anyway, you'll implement it in this week's lab. Now, the last thing I want to talk about is it's just a use case, really. Number one, it's a use case for the actual provider pattern, so it fits in nicely in this sequence. The other aspect to this last topic that I want to look at is how do we implement what I'm calling protected or private routes within our React app. So this is tying together both navigation and the provider pattern, the two kind of topics that we've been discussing so far. By a protected route or a private route, what I really mean is there may be certain parts of your app that can only be accessed by the user if they have logged in. It's as simple as that. But how do we force users to log in order to access particular pages? Now, I have, as I'm wont to do, have a simple sample illustrating this. And this sample is the last of the samples in the routing set of archive that I've given you already. So it's sample 8. And so if we just run sample 8 first, so the idea is here are the different pages that make up my app. The home page and the public page are accessed without authenticating. And you'll notice here on the top as well, it's telling me that I'm not logged in at the moment, which is just fine. And I have the option here of clicking on the login button, which would bring me to my login page, Maria, and I'd fill in my username and password, which I'm not really interested in. And I click on my button to trigger the validation. Now, so I can access the home page and the public page without authenticating, but these two pages here force me to log in. And so, as is typical, if I try and access, let's say, the inbox page, which presumably would have my personal emails, then the app actually redirects me to the login page immediately. And then when I do fill in my credentials and click on the submit button, okay, behind the scenes, they're validated, etc., etc. And if everything is clean, then it sends me to the page that I want to get to. So it somehow remembers that I was trying to access the inbox page after a successful authentication. And now, as well, it's telling me here on top, it seems to know that I have logged in because it's changed the message. Usually would include maybe my name here as well, but I've just left that out. And if I want to sign out, it's now giving me this button here. So this header has changed depending on whether I'm logged in or not. And if I sign out, then it sends me back to the home page. If I just do that again, log in. Of course, now I can access the profile page, which normally would require me to log in, but because I've already logged in, I can access that directly. So it's usual kind of user experience that you've come across in lots of other websites. Just bear in mind that there are two ways that I get to the login page. I either get to it by trying to access a protected route. So this is the term that we would use for these two routes here, the inbox and the profile. There are protected routes or private routes. So I can get to the login page by trying to access them, or I can go directly to the login page by just clicking this login button here. And if I do that, then clearly there's no way the app knows where exactly should it send me after I successfully logged in. So by default, it just sends me back to the home page. But I am logged in now, and so I can now go directly into my inbox or my profile. Right, that's the user experience. So how do I implement all of this? And so essentially what I want to implement are this notion of protected or private routes within my routing configuration. And the React Router library, as it turns out, doesn't provide a solution for us. So we have to come up with our own custom solution. Now, if you Google on the web, you'll get lots of solutions to this problem. And that's essentially what I did. And I found one that I thought was particularly it had a particularly nice implementation in terms of its declarative nature, etc., etc. So overall, anyway, we would like a clean declarative style of implementing this protected routes problem. And in terms of this declarative objective in our solution, this is maybe how we would like it to appear in our routing configuration. So we have our normal root entries. Here's a root entry for the inbox path. And it's hopefully it's telling us quite clearly that if you want to access this path, well, this is a protected route. Now, this component here, protected route, is something that we have to implement. And presumably behind the scenes, what this component needs to do is to determine whether the user has logged in or not. If they have logged in, then mount the inbox component straight away. In other words, mount that page. If they haven't logged in, then redirect the user to the /login route. And the /login route, which I have up here, change the browser's URL to /login. That will cause the login page to display. Behind the scenes, that's going to display my username and password. When I click the submit, it validates those. And if everything is fine, then it changes the browser's URL back to /inbox, which means that this component is going to mount again. But on this occasion, it is actually going to allow the inbox component to be mounted because it will discover that the user has now logged in. And so that component can mount. But at a very kind of high level, I think we'd agree that this implementation, even though we haven't seen the detail, is clear and declarative in its style. In particular, this component is making very clear that this route, this overall route, is a protected route. So some elements of our solution will be, we're going to use a React context to store, what I'm deciding to store is the current user's token. You know, typically the way authentication works is the user enters their credentials. Those credentials are typically sent to a backend service, which validates them. And if they're valid, then typically the backend generates a token and sends that token, and that token has an expiry timestamp associated with it. But that token is then sent back from the server side back to your client. The client typically stores it internally, and the existence of that token means that the user has logged in. If the token is null or undefined, then that indicates the user hasn't logged in. But there are lots of components or pages within our app that may need to check, is the token valid, or does it exist, or is it undefined? So hence that is shared data. And so we've already discovered a React context is where we should store that shared data. We're going to have programmatic navigation. There are a couple of instances of it. You know, when you're redirected back to the login page, if you try to access a protected route and you're not logged in, that's programmatic navigation. We also will have programmatic navigation after the user logs in successfully, when we need to send them to the page that they wanted to access initially anyway. And thirdly, our solution is going to have this, what I'm calling the remember the user's intent aside to it. Somehow the application, after the user tries to access a protected route, but they're sent to the login page, the application needs to try and remember where were they trying to get to before we force them to log in, so that the application can can redirect back to that page again without the user having to manually do it themselves. That's quite tricky actually as to how you achieve that, as you'll see in a second. So again, I'm just showing you excerpts from the overall solution, although I do provide the overall solution. So the auth context is the first part that I'm showing you. And here's my shared data, essentially, my token. And it's just I'm initializing to null, so that's my way of indicating that the user isn't currently logged in. You might remember the use location hook every time the browser's URL address changes, the React Router library creates what's called a location object. And that location object has a number of key value pairs. Most of them, to be honest, aren't of interest to us, but there is one key value pair. It's called the path name key, and it contains a string, and the string is essentially the current URL address or the new URL address that has appeared in the address bar. So the use location hook allows us to access that location object, and that will become useful to us, as we'll see in a while. The use navigate hook we saw there a while back, that will allow us to implement programmatic navigation. Now, if we skip over, of course, up here on top, I'm creating my auth context, my orange box again, if you like, which is empty initially. And down here, okay, I've got two functions. I'll come back to the detail of them in a second. Both of these functions actually are concerned with changing my state variable, my token, but they're just two functions. And eventually down here, then I'm showing you what am I putting into my orange box, into my auth context. Well, I'm putting in the token, and I'm putting in the two functions that I've declared above, because it's other components that are actually going to be invoking these functions, as we'll see in a moment. So in this case, my context is not sharing just data, it's also sharing functions or making them available to other components. If we go back to this guy, clearly from the name, this function is invoked when the user clicks the submit button on the login page. And so whoever invokes that function, well, it's going to be the login page, it's going to pass the username and password. We didn't care about the details of where these are coming from now. And what does the function do? Now, in real life, what this function would do is it would probably make a fetch call to the backend, passing the username and password, and that backend functionality would do the validation and it eventually return a valid token if the combination was correct, otherwise return some sort of error message. But we don't want to get bogged down in that kind of detail. So I'm just kind of mimicking that behavior by using the set timeout function. I'm sure you've come across the set timeout function before. This is just a function that's built into the JavaScript language. You pass it two arguments. You pass it a callback. Here's my callback. And you pass it an integer. And as you may know, the way the set timeout function works is it invokes the callback after this period of time has elapsed, and we're expressing time in terms of milliseconds. So really all I'm doing there is kind of simulating a delay between a delay associated with the validation of the user's credentials, because it would normally be an asynchronous communication. It's what I'm doing inside the callback is interesting though. I'm setting my token to, I'm just hard coding it to a string. And it doesn't matter what the string is. The impact though is that by setting the token to something other than null, that now means that the user has logged in, or a user has logged in. That's fine. Now what's going on here? Now there's a couple of things that I need to explain about this particular line. First thing is, it's just a JavaScript thing. When you've got an expression like this, so I'm saying const some variable equals something, or this is the or operator in JavaScript, something or something else. So the way this is evaluated is the thing to the left of the or is evaluated. And if that overall evaluation is a Boolean true, then the result of the evaluation is assigned to the variable on the left. If it evaluates to false, then the thing to the right of the or is assigned to my variable on the left. Now, for now, just take it from me that this expression here is going to evaluate to the URL that the user was trying to access before they were forced to log in. So, for example, that might be /inbox or /profile. That's what this expression is going to evaluate to. I'll break down the expression a little bit later on, but it's going to evaluate to a string. If the user, it's going to evaluate to a string if the user accessed the login page as a result of trying to get into the inbox page or the profile page. In other words, they were redirected. And so if that is the case, then essentially what we're setting origin to is we're setting it to the URL that the user was trying to get to before they were forced to log in. I did mention to you that there are two ways that the user can bring up the login page. One is if they try and access a protected page and they're forced to log in. The other one is if they actually clicked the login button at the very top in my header. I just go back to it. You know, if they click this sign out, if they click this button here, that will bring them to the login page. Now, in that case, as I said, where the application, I've just arbitrarily decided that the application should send the user back to the home page, assuming it's a valid login. And so that is what I am doing. That's why we've got the slash string here to the right of the R. So if the user is logging in as a result of going to the login page directly themselves, then we want to assign the slash URL to my origin variable. And what am I using the origin variable for? Well, I'm carrying out programmatic navigation with the origin string. Origin is always going to be a string. It's either going to be this string or this string. Either way, I navigate to that URL. Right. I'm not showing you the details of the sign out function. Really, there's only a one-liner in there, and it will be to set token back to null. And we know what the impact of that is going to be. So this is quite tricky here now. Note, just dig a little bit deeper into it. I am using the location object. That's kind of significant, but we'll come back to it. Here's another few excerpts from my implementation. Here's a typical route. This is the one that we showed earlier on. So I'm just repeating that here for reference purposes. Here's the actual protected route component, the one that's mentioned here. So when the user tries to access the login page, the inbox page, and they're not logged in, this component is mounted, which means this component executes. So what does it do? First thing it does is it tries to, or it uses the use context hook in order to access, in particular, the token stored within the context. I'm not interested in the other parts that are stored inside the context, just interested in the token. So I'm just accessing the token here, which could be null, or it could have some other kind of string in it. I'm also interested in the location object. Now, here I'm just checking to see and note the not operator here. I'm essentially checking to see here, is the user logged in or not? And the way I'm doing that is checking the current value of token. Is it null or is it something else? If it's null, then by notting that, sorry, now I should just go back again. In JavaScript, we talk about truity or falsies. When is something true or when is something false? In JavaScript, any primitive value or any object or any array, if you use an if statement with a variable that is assigned a valid primitive or a valid object or an array, then that variable from a Boolean point of view, evaluates to true. If a variable is assigned the undefined value, or if it's assigned null, then that variable from a Boolean point of view evaluates to false. So null or undefined means false. Anything else essentially is true. So that means that this statement here is essentially saying, if there's nobody currently logged in, then do a programmatic navigation to the /login page. Or to elaborate, change the browser's URL to /login, and that triggers the routing configuration to be reconsulted, and the login page is displayed. And that would be the case, right? So if going back to here, the user isn't logged in, which means we don't want them to access the inbox page yet. In other words, we don't want this component to be mounted yet. And so my protected root implementation is achieving that by means of this condition statement here. It's sending them to the login page. Otherwise, so if this override expression evaluates to false, and it would evaluate to false if the token had some legitimate value in it other than null or undefined, and by notting it, that overall expression becomes false, so it skips over it. In that case, we're returning children. What's children? Well, in this case up here, children is inbox. And so now the inbox component is mounted, which means the inbox page is displayed. Now, coming back to here, though, there's a little bit extra going on in my use of the navigate component here, and it is what's going on down here. I said that every time the browser's URL address changes, the React Router library creates an instance of the location object. And I'm showing you up here what the typical structure of the location object is. And we've talked about this location object before. The path name property is important. The rest isn't really. But you can add some extra information to the location object. And you do that by means of this state prop here. In my case, what I want to do is I essentially want to store in the location object where the user was trying to go to before we forced them to log in. And so how am I doing that? I'm storing in my state. I've decided to call, my state is going to be an object. My key is arbitrary. I've called it intent. The value that I'm assigning to that intent key, though, is location.pathname. And location.pathname will actually have the URL that the user was trying to access. So I'm essentially kind of passing this information, if you like, I'm passing it on to the login page so that it can get at it subsequently. And if I go on to the login page, the login page is also accessing the context, but it's only interested in the authenticate function. Skip over this for a second. Here it displays the login page. I have my button that I click, which triggers this event handler. Now I'm just randomly generating a password using the math function. And I'm calling the authenticate function that's stored above my context, and I'm passing it in a username and password, which I've just hard-coded. The authenticate function, if I go back to it, is here, which we've looked at. Now, if I come back to this part here, location.state.intent, just forget about the question mark for a second. Location.state.intent, that now corresponds to what I was trying to do here. Here I'm setting up state.intent, so that when eventually the protected root component and its authenticate function executes, it can actually pick up that value. In other words, it can find out where was the user trying to go to before they were forced to log in. And now we're sending them to that location because we've validated their credentials and we're assuming they're okay, and we're sending to that page. Now, I've left out the use case where, supposing the username and password were incorrect. I've just ignored that error case for simplicity's sake in this illustration. So although we're only explaining a very simple use case, log in, log out, the implementation is actually quite tricky. I think that we can all agree on that. But we are using the primitives of the React Router library, all of which we've seen already. Now, is there more in this? Let's see. Okay, this is the login page. This is kind of where we left off. Don't think there's anything there that I need to talk about. What I actually did, as much for myself as anything else, really was to try and describe the flow of execution that's going on here. Now, I was trying to use one of the standard UML diagrams, if you're familiar with UML, and really none of the UML diagrams fitted what I was trying to explain. So this is kind of a makey up diagram. But you can study it later yourselves, but I'll just walk my way through it. So the user clicks the inbox link, let's say. And so in my square box here now means that the browser's URL address has changed. When the browser's URL address changes, React Router creates a location object, which I'm representing over here on the right. And in this location object, there's nothing interesting other than the path name key in that location object has the URL, the current URL of the browser. That's fine. Now, when the user tries to access the /inbox root, based on my routing configuration, the protected root component kicks in. It sort of intercepts the routing configuration. Now, if I go back, what I mean by that is, sorry now, if the user tries to access the inbox, this component steps in and deals with the user's request, if you like, before this happens. Okay, so it kind of intercepts. So here we have the protected root component. Now it's dealing with the current situation, if you like, and it can see this location object. It makes a decision, is there somebody logged in or not? And we know how it does that, checks the token. If, let's say, they're not logged in, so it goes down this route, it changes the browser's URL address again to /login. Let's go back and check that. Here, checks to see, is there somebody logged in or not? If they're not, change the browser's URL address to /login and do this extra bit as well. So it changes the browser's URL address to /login, which means a location object is created. But this location object has this additional data that I've decided to add into the location object. And I've already explained what that additional data is to you. Continue on the flow. The protected root component, because it has changed, because the browser's URL address has changed to /login, the React Router consults its routing configuration, and this is a normal case. It just loads the login page because we have a normal route in our routing configuration for the /login case. So the login page mounts on the screen and it executes. In particular, what it does is it calls the authenticate function stored in my context. I'm going to go back again to check that. Is that right? Yeah, when the user clicks the button, this executes and it calls the authenticate function, which is up in my context, which is associated with the context provider. And if I go back one more, maybe we can kind of remember that. We can take a snapshot of that now, but this is the key part here, I suppose, here as to what it does. Let's go back to my diagram. So the authenticate function, which is contained within the auth provider, it does what it does, and assuming the username and password are okay, it carries out a programmatic navigation. In other words, it changes the browser's URL address to /inbox. Where did it get that from? It simply got it by consulting this location object here. This is the most recent location object that was created. And it digs it out from here. Sorry now for jumping around, but if we go back again to here, location.state.intent gets that value and assigns it to this variable and navigates to that. And we know now that that expression is going to be equal to /inbox. So we navigate to /inbox. Back to my diagram. We're back up here again. This component intercepts yet again that, but on this occasion, the token has a value in it. So it comes down here and the inbox page is mounted. Why is that? If I go back, this overall component, if you like, the flow of execution kind of falls through this component, and it returns children, and children in this case is inbox. So the inbox component is mounted, i.e. the inbox page displays. So I don't know if that diagram helps you. You would certainly need to step back from it and maybe go through it yourselves and then cross-check it with the code in order to understand the flow of execution. It's quite tricky though, let's be honest. Now, the actual implementation is sample 8. And if we expand sample 8, I thought it was a good idea at the time, but I'm not sure if it really was a good idea on hindsight, but I left it there anyway, in that I've got 2 versions of this thing implemented, but it's really version 2. And in order to get version 2 working, of course, you have to go to your base index.js, which is, there's so many index.jsx, this one here, change that to sample 8, which we did. Then when you go into the sample 8 folder, it has its own internal index.js, and you set that to either version 1 or version 2. I'm not sure if looking at version 1 is really going to help you. Version 2 has everything and a little bit more of what I've been explaining so far. Maybe if I go back to my slides, because I have some notes on it now. Okay, there's a couple of notes. I want to go back, first of all, to that question mark that you saw. I know now I'm jumping around the place, but if I go back to here, you see here where I have location.state question mark dot. This question mark dot is what's referred to as the optional chaining operator in JavaScript. It's another one of these ES6 things that was introduced. And what is it? So I'm saying the optional chaining operator, this question mark dot, it accesses an object's property. So it's like a normal dot operator, but it accesses an object's properties. And we're told if the property is undefined, which means it doesn't exist, or if it's null, then this operator, it returns it kind of short circuits the rest of the expression and returns undefined. Essentially, it's a way of avoiding your program crashing. So I've tried to just give you an example of it here. Supposing I've got this var1 and I've assigned it an object, an empty object, just for simplicity's sake. And the next line here, I'm going var1.foo. Now, we know from before that var1.foo is going to evaluate to undefined. So var2 will be undefined. That's okay, my program won't crash. But on the very next line, I'm going var1.foo.bar. Now, this expression is now going to cause my program to crash because why var1.foo, that evaluates to undefined, and I'm trying to access the bar property of the undefined primitive. And we know from before, hopefully, that that will cause my program to crash. However, if I wrote the expression like this, var1.foo optional chaining operator .bar, that the way that's going to work is it's going to evaluate var1.foo. It's going to see that's undefined. So it essentially then short circuits. It doesn't bother evaluating the rest of the expression because it knows if I evaluate the rest of the expression, then that is going to cause my code to throw an exception. So we say that it short circuits the rest of the expression. And, you know, you can use this optional chaining operator as many times as you want to. Why this optional chaining operator is useful is if you've got an object structure and sometimes particular properties in that object structure exist and sometimes they don't, and that's considered normal, but you want your code to deal with both scenarios. That's where this optional chaining operator comes in. So, you know, in this example here, clearly it's going to short circuit here, but there might be other occasions when the foo property does exist within my object, in which case I wanted to continue on and evaluate the bar part. Bar may exist sometimes and other times it may not. If it does exist, then it may have a baz property, but I'm using the optional chaining operator there again to short circuit just in case var1.foo.bar actually overall evaluates to undefined. So, and so that's why if I go back to my particular usage of it, if I flick back yet again, in the scenario where the user goes to the login page directly themselves, that will mean in that case location.state is going to be undefined. And so we don't want our code then to try and access an intent property in that case, because that would now cause this line of code to throw an exception. So if I did not use the optional chaining operator there, and I just use the ordinary dot operator, then every time I run my application, this line is going to crash, cause my program or my application to crash. So that's why I brought it in there. That's the optional chaining. And as I was talking about there a moment ago, in the code that I provided you with, there are two implementations, version 1 and version 2. Version 1 just has the auth context. It has the login implementation, but it doesn't have predicted routes. So it's a kind of a stripped back. The idea in my head at the time was maybe you should first of all look at version 1, make sure you fully understand all of that, and then move on to version 2. But you can decide for yourself. Version 2 has the full implementation. There is something as well in version 2 that isn't in the slides that I've shown you there. And again, I've just left it out to try and reduce the complexity, if you like. If I drill into version 2 and go into the auth context, this line here, like in a real life application, what you would need to do on this line here is to make a fetch call to your backend authentication service. And I've just kind of faked that. I've implemented this fake auth function, which is here. Where is it? There it is there. So that's where I'm using the timeout there. Instead I've kind of delegated it down there, but it's just returning, you know, sorry, no, 1 second. My computer is running out of battery power.
Thank you, on mute.
Yes, I was on mute. Yeah, thanks for hanging on. My computer crashed. You saw what I typed up on the Slack message anyway. My computer had just run out of juice. I thought I'd got it in time, but I hadn't, and it just died. And then when I brought it back up, Zoom kicked in and it started converting the recording. So I didn't want to interrupt that because potentially there would be no recording at all. Anyway, either way, I've finished what I wanted to cover with you today. So there's nothing lost unless there are any questions. I know the stuff I was covering there at the end is tricky enough stuff, which means you got to go back and look at the code and study it for yourselves. There may be some questions that you might have on it to clarify it, and that's fine. You can put those to me in the lab if you have them, or in next week's lecture. Next week, I only have a small amount of stuff that I want to cover with you. And as well, what I will do, which I think I mentioned at the outset, is I will give you an introduction to the specification, or a kind of a breakdown on the specification, and explain it as best I can, and then hand it over to you. So if that's okay, we'll call it a day, unless there are any questions that you have for me. I can go back to the stuff that we were covering now by all means, because we've got some time left. If you want me to explain, re-explain some stuff that I was discussing there. No. Okay, folks, we'll leave it at that for today, and I'll touch base with you on Thursday and talk to you on next Tuesday. Thanks a lot.
Thank you.